Hello. Okay. Hello, everyone. Please welcome John Willem Jansen and Marcel Offermans, who will be speaking their talk on Polyglot Provisioning with Apache ACE. Please welcome.
Thank you very much. Well, we are already introduced, but let's do that another again. These are not my legs, actually, but this is me. I'm a software architect at Luminous Technologies. This is my boss, Marcel. My relationship with Apache is that I'm a member and a PMC member of Apache ACE and Apache Felix. And I also, although not quite actively, a mentor for the Milagro project that is standing outside with a large booth.
Okay, let me introduce myself as well. So I also work at Luminous Technologies, the director there, but I still very much a hands-on approach, working on technology, working on open source projects. Like Jan Willem, working mostly on Apache ACE and Felix, member of the PMC there, and also a member at Apache. Did a few incubating projects as well, but at the moment, all of those have sort of graduated to top level. So looking for a next challenge in the incubator. I think there's lots of new stuff coming there, so we'll see how that goes. But let's get started. A brief outline here of the talk this morning. I'll start with a brief introduction of Apache ACE. I don't know how many of you have heard of it. No, okay, that's good. Then I won't skip that. And after the introduction, we'll look a little bit closer at the management agent, which is one part of ACE, and that's also the part that we'll implement in a different language. We chose Go because it's a cool language, and we had to pick something. But basically, the example that we have could have been done in any other language. At least that's the point we're trying to make. To prove to you that it's not just talk and slides, we also have a demo, and after that we'll have a short wrap-up. So let's get started by introducing Apache ACE. And I don't know if you were in the keynotes yesterday, but I think it was Rich who said that every project on the homepage should have a short description of what the project is about. This is literally the first sentence that we have. So Apache ACE is a software distribution framework. It allows you to centrally manage and distribute both software components, configuration data, and basically just any other type of artifact that you want to deploy onto your system. It can be anything like firmware or data or whatever. And we'll give some examples of that later as well. So diving into Apache ACE a little bit more, what problem does it solve? So I already said it's about software distribution and centrally managing it. So we deal with deployments. Deployments can consist of all kinds of different modules. By default, we are targeting OSGI-based systems. So those typically have maybe hundreds of different modules if you have a reasonably scaled OSGI application. We might ship some configuration data and some other artifacts as part of deployments. And we can send those to different target systems. I've drawn 3 in the slide, but obviously there can be a lot more than that. And when you're talking about all kinds of embedded IoT devices, it's usually a little bit more than 3. They can be completely customized, so every target can be different. And ACE basically keeps track of which components go to which target systems and tracks that over time. So we get a lot of questions about, so how does ACE compare to some other solutions out there in the market? I mean, there's a lot of them. Probably missed most of them on this slide, but these are some of the popular ones that we get asked about a lot. First is really a family of solutions, Chef, Ansible, Puppet, Salt, which are all tools that are very scriptable. They use different scripting languages, but in general you can do pretty much anything with them. Typically they're used to manage clusters of servers on data centers, and used in DevOps-like operations, also sometimes just system administrators working with them. But not necessarily targeting small devices, at least that's not typically where I see them being used. Another famous example, the Google App Store or the Play Store for Android. That's another one, huge. It has a built-in store. It's a little bit different in the sense that the end user using some kind of device is usually also in control of what gets installed on a system. You actually have to buy stuff or get it for free. And so you're mostly in control. There's a lot of stuff they push to you automatically as well, but most of the things you can still choose there. So that's a little bit different because with ACE we're just centrally pushing stuff, and our devices might not even have users working with them all the time. Then RPM, APT, Debian packages, I mean those are more low-level building blocks. You could use them basically in any of the other solutions on the slide. And finally, a little bit more in the OSI space, we have Eclipse P2 and Apache Karaf, which also has some sub-projects that can deal with deployment. They're quite similar to what ACE does, but also maybe a little less focus on the central management part of it. So that hopefully gives you a little bit of an idea what ACE does and how it differs from these solutions. So let's take a look at the high-level building blocks of Apache ACE. And we basically have 4 of them. A client, we can have a server part, a repository, and an agent running on some target. And this is just a logical view. In a typical deployment, you'll have multiple servers because you want redundancy and failover and stuff like that. You might have one or more repositories. Clients depends a little bit on your use case, if you have many of them or just want to control the whole system. And targets, you will have many. So zooming in on the client first. Client is actually the subsystem that you use to make changes to the whole configuration. So if you want to add new artifacts or change the way they are mapped onto the target systems, that's something you'll typically do on the client. And we have different clients in ACE. We have a web-based one, which is great for doing demos, but really bad if you want to automate stuff, because you don't want to drag and drop stuff by hand. You want to completely script that stuff. So for those use cases, we have both a REST-based client and also a scriptable one, which uses the Felix GoGo shell as a scripting language. Could have used another one. It's probably not that hard to write that. And you interact with the ACE server through a sort of a checkout commit style interaction. So if you want to make changes, you do a checkout of the current situation. You make your changes, maybe add a few new artifacts or new versions. And finally, when you're happy with what you did, you commit those changes back, and at that point they will be activated. So Jan Willem will demo a little bit more of that later, so I'm not going to go into a lot of detail on how the UI works. But in short, we have artifacts, targets, and we have some grouping mechanisms in between to make those a little bit more manageable, because we probably have too many artifacts to handle them one by one. It's a little bit like browsing through an IKEA catalog, I'd sometimes say. IKEA also sells modular furniture, right? But you don't order all the individual parts. You order like a bed or a couch or something, and associated with that is a large number of parts. Unfortunately, you have to build it yourself there. We can assemble it for you, but I think that's a reasonable analogy to use. Then moving on to the server part, that's the part that actually hosts all the configuration data and that you configured through the client. We can easily replicate that. A typical setup will probably contain multiple servers, so you can scale out better. And the server really is the central hub. It interacts with the client, as I just told. It also interacts with all the different targets that are there, and maybe also with other servers. We can also create sort of proxy servers or relay servers if we have to distribute the load. If you have lots of different targets that very regularly poll a server, you might overload a single machine. So we can scale out to different relay servers that way to distribute that load. And another feature that is part of the core design of Apache ACE is support for multi-tenancy. So you can have different configurations for different customers all in the same server. Then we have a repository, and that for ACE is just a place to store all the actual software artifacts, configuration data, etc. It has only 2 requirements. You should be able to add new stuff to it, and all the existing artifacts should be referenceable through a URL. We ship with a repository out of the box, but you can use any other repository as well. So if you're already using Nexus or some other implementation, you can also hook that up. And the final part is the agent, and we ship with an OSI-based agent because that's our primary use case. We assume that the target that you deploy this on already has a JVM running. We can ship the OSI framework as part of ACE as well. You can also use it in your own OSI framework. It's compatible with all of them that are out there. And really the agent is just a lightweight and updatable, self-contained bundle that you add to your target. Incidentally, there's also an Apache Celix project. I'm not sure if you're familiar with that, but that's a C implementation of the OSI specification. So everything we in Felix do in Java, they made a way in C to do the same thing. So they created reloadable modules for mainly embedded C systems. And in that project, they also created an agent that can talk to ACE. So we can also provision C modules to really small embedded systems. And later on in the presentation, we'll see how we can build a Go-based agent. And like I said, it could be any language. It's just one we chose. And I'll go into a little bit more detail on how the agent works in a couple of slides. A couple of other things to tell about ACE. One is a couple of examples of how you typically use ACE. We use it a lot in continuous deployment, so then we really make it part of our build, end result of the build after running some unit tests and other stuff is a set of artifacts, and we use the scripted ACE client to actually take those artifacts, upload them to ACE, and then have ACE automatically deploy a new version of those bundles to a set of targets, usually testing QA systems, but it could also be directly to production, depending on how confident you are that once the test passes, it will actually work. So when you're not that confident, you might want to split that up, have 2 separate environments. One way do all your QA testing and continuously deploy basically on every commit that you do or every pull request that you merge. And then have a second environment that is your production system where once you've fully tested all the artifacts, you sort of copy them to the production environment and then deploy them to your customers. So those are 2 typical scenarios of how to use ACE. And I mentioned before that it's quite easy to add new types of artifacts to ACE. I'll explain briefly how you actually do that. You need to create 3 services for that. The first is an artifact recognizer. That's just a piece of code that you write that can actually take some kind of artifact, look inside or look at the file extension or however you identify such a file, and it will either tell you, I have no clue what this is, or yes, this is a firmware image or a jar file or whatever. And once you've established that, there's a second service, the artifact helper, and that more or less contains some helper methods to extract extra metadata out of the artifact, so you can use that in the ACE client. And it has some other methods that help you deal with the artifact and use it and deploy it. And the final one is a resource processor, and that's actually a bundle that gets shipped alongside this artifact that you are now deploying to a target, because on the target itself, you probably need to do something to actually install an artifact. If you might have a firmware image that you need to copy to some memory location, or you might have an RPM package that you want to RPM install. So in a resource processor, you actually can write some Java code that does this installation, can also do an uninstall. So that's a powerful mechanism to install new types of artifacts, even onto targets that have never heard of this type of file before. It's, well, leveraging OSGI there and making it really dynamic. And we'll see some of that in the demo as well. So now zooming into the agent itself, briefly discussed what it is. So it's an agent running on a target, it's self-contained, and it controls the life cycle of the application that's running on that same target, or vice versa. Depends a little bit on your use case. If your application does things that shouldn't be interrupted, for example, it's probably a bad idea to do an update in the middle of something really important. So there is some interaction possible between the application and the agent. Application can tell the agent, well, this would be a bad time, don't update, even if there are updates, or the other way around, this is a good time, go and install the updates for me. So the agent is responsible for that, downloading the updates, installing them. We can stream them, or we can first download them and maybe a little bit later actually install them. Depends on how much space you have on the device, how much effort it might take to download such an update. We've had cases where people are still using slow modems to download software updates. So we might not even make it in one go, so we can also resume downloads and stuff like that for those scenarios. And then finally, when the stuff is there, we can install it. During installation, we also have a couple of different strategies. The most simple ones are either whenever we do an update, we stop the application, perform the update, and then restart it. You could argue that's not very OSGI-like, because you don't need to stop the whole application. So another method we have is that we actually only update the bundles that need to be updated and leave the rest of the application running. And through all the service dependencies and components that you've defined in your OSGI application, you should be able to handle those dynamics anyway. So really can do updates while everything's still working. On top of that, we also provide some kind of centralized logging system. We monitor the actual life cycle of the target, so what updates are installed, but also when somebody turns off the target, turns it back on, stuff like that, we can log all those life cycle changes and copy them to a central location, so they're also available if you cannot at that moment access the actual device. So we aggregate that. Going over the whole process step by step, the agent basically, once it gets started, it might be idle for a little while, might wait for a while. Then it will try to upload any new log information if there have been lifecycle changes. It might check for an update, ask the server, do you have anything new for me? And then, well, either there is something new, and then that will be downloaded and installed, or there is not, and we go back and wait again. And that's basically the most important steps that the agent does. Briefly talked about the audit log, which logs all these lifecycle changes. So that's something we do on the actual target, obviously, because there we can see what's going on. We cache that on the device, and whenever we can connect to the server, we synchronize that data back. Contains stuff like starting and stopping bundles, performing updates, maybe failing updates, etc. And it's basically just a set of events. So just sending out events and collecting them on a central location again. And then to the actual deployment packages that we use whenever we do an update. Just diving into the format a little bit. They are just jar files, just like bundles, OSGI bundles are jar files. Deployment packages too. And it has some extra metadata. It has a name, it has a unique version. It's based on the semantic versioning that is used in OSGI a lot. And it also has a list of all the artifacts that are part of this deployment. So they are first in the metadata, and there might be something in there like this artifact is no longer part of the next update or stuff like that. And then after that, in that same jar are the actual artifacts. So you first get the metadata, so you already know this is what's going to happen, and then later on in the stream you get the rest of the data. And the management agent handles all of the information in the deployment package, and it uses actual transactional updates to make those changes, install a new update. If anything goes wrong during that process, it will do a rollback, so it will go back to the original situation. So you don't have to worry in your application about getting maybe 2 out of 5 new bundles and not the rest, because that usually messes stuff up in some applications. You might be very robust and can handle it, but usually it makes sense to either get everything or get nothing. I already discussed the different stop the world or doing live updates. And during the transactional update, we also write some extra data in that audit log, send it back to the server, so server also knows that, okay, this update has really been applied on the device and it works and it's now running. So with that introduction to ACE, I hand over to Jan-Willem.
Yes, so Marcel briefly talked about the whole infrastructure that ACE provides you. And one of the common questions we also get about ACE is, it's largely based on OSGI, I can only do OSGI provisioning with it. That's actually not true, and that's the whole purpose of this presentation actually. We've written an agent in Go, and by that we can show that ACE is actually capable of provisioning any kind of artifact to any kind of agent that you'd like. It provides you a whole rich infrastructure that you can reuse for different purposes. So our goal for our management agent that we've implemented is, well, write a simple implementation in Go with all the boilerplate functionality in place to talk to the ACE server. So making REST calls, interpreting the deployment packages that we obtain. And for this demo, we have created a simple Docker container deployment. Why? Because Docker is the new hip kit on the block, so why not do that? For this demo, we've actually running on a Raspberry Pi that's lying before. And it implements the same update cycle that Marcel explained briefly before. Before we dive into some slides of actual code, let me first introduce what we are going to show. We're going to show the main overview of the actual agent itself and show you the various topics that you need to do, such as log synchronization, the update check, download deployment packages, how you pick out and extract the Docker file, and the installation that consists of several steps. First, I have to create a tarball and pass that on to the Docker daemon. We have to create a Docker container that contains the actual image that is built using the Docker file. We have to start it, and we can retrieve the logs. And all this is part of the demo. Who has any familiarity with Go language already? No, not yet. Well, I've hoped that was the case. So I've put in a lot of code, but hopefully it's readable enough for you to understand it, even if you don't have detailed Go knowledge. So this is the main logic actually of the management agent in Go. We have to know where the server is running and how the target is named. As you remember, we have several targets that we can deploy to, so each target has a name, a unique name that we can use to identify it. We create a new agent. The agent is a couple of lines of code that contains all kind of convenience and boilerplate stuff to be able to talk to the ACE server. And we start the main loop, which is simply a delay that gets invoked each 5 seconds in this case, and gives us a callback. And when we receive that callback, we do two things. First, we synchronize our logs with ACE, and then we check and download the updates. Again, we have made it quite generic boilerplate code, so we pass in a function pointer or a method pointer, a method handle in Go that does actually something with the deployment package if such a deployment package is received. Onto the log synchronization. Here we create first a URL. This is, we have to know where we have to talk to, so if we abstracted that away. And we make a simple REST call, which we pass in the target name of the agent and the log ID. As you probably might have heard from Marcel, there's an ability in ACE that you can have multiple logs implemented. One requirement is that you have an audit log, which contains the life cycle of the management agent itself, but you can create any number of additional logs for your own purposes. For example, for your application data, for your health checks, whatever. For this demo, we've repurposed the existing audit log already, and that's merely for simplicity. But if you would use this in production, you probably would have to would like to use a separate log for that. So we first ask ACE, what is the last version range or the last range of IDs of the log that you already know? Because in this case, we want to have the ability to upload only those log lines that have actually been added and are not yet known by the server. So we first retrieve the range of log IDs that are already present on the server. And with that information, we prepare the feedback. We're not going into that detail how that works, but it simply does cut off the log entries that the server already knows and only appends the log entries that the server doesn't know. Once that log data is present and created, we create a new call to the ACE server in which we post the log data back to the ACE server. Hopefully that's understandable for everybody. It's merely a couple of REST calls that you have to implement. Onto the download and the update checks. As mentioned, this is boilerplate code, or more or less boilerplate. It takes the deployment package handler, and first we call again to the ACE server with a simple REST call. What versions of deployment package do you have for me? The agent is stateful, so it should know already which deployment package is installed, what version it has installed. And that information we can use with the versions that are returned by the ACE server to determine whether or not a new version is available. And you can use that information to implement various strategies for updates. In this case, we have used a simple go to the last version that's available. But you could also use an incremental update. Go by each version that's available until I reach the latest one, or whatever version implementation strategy you'd like. Once we have determined that there's something to actually install, we log something, well, that's not that interesting. And then we create an actual URL, a new URL to obtain the actual deployment package. So those steps are actually separated from each other. And once we have the deployment package in place and obtained this information, we pass it on to actually install it. So how does that installation works? Well, actually, a deployment package is a jar file or a zip file. And we iterate through it, through each of the files, and check if it has a certain name which corresponds to the manifest. And the manifest is kind of a recipe that contains the actual metadata of the deployment package, like the name, the version, the contents. And once we have that information, we know actually this is a deployment package we can do something with. So we create information, we get to obtain information about the name and the latest version it contains. And all the other files in that zip file, we append to an array for later use. And here's the actual information. This is perhaps the most important part of ACE code. Here we start by adding a log entry to the audit log, stating that we are about to install a new version, containing the name of the deployment package. And this is an indication and will be useful in later on to determine what was happening at what time on your target. Again, we're talking about embedded IoT devices, so you're not probably able to go there and turn on the monitor and see what's happening there. So you need that information later on to determine and correlate if something went wrong, or you want to know what was running on there at what moment in time. This calls out to the actual installation. In our case, this calls out to do the Docker container installation and creation. And once that's done, we add information again to the log information, to the audit log. This is merely optional. This is not mandatory required. The only thing that is required is the last line, which states the actual result of the update handling. So here we state that the installation is complete for this deployment package with a Boolean stating whether it was successful or not. And we also log the actual information of our actual version that's currently installed on the management agent. So how do we actually call out to Docker? Well, fortunately, you can call directly to the Docker daemon, and calling to a socket on Go is actually quite easily to do. And we can, in this case, use a cool library from a guy that has a complete Go implementation of the Docker API for us. First thing we do if we obtain the deployment package is extract the image name out of it. We could also pass this in through the deployment handler, but that's not what we've done. We've extract it from the deployment package because we assume that the deployment package contains a Docker file. Then we create a pointer to the Docker client. And for this demo, we've made the situation that we pass in a raw Docker file, and this Docker file needs to be turned into a Docker image before we can actually start the container. So we have to create a tarball which contains the Docker file and maybe additional files that you want to put into your Docker image. And we hand it over to the Docker client to build an actual image. Alternatively, we could have implemented this the other way around, which is probably more reasonable to do or more sane to do. if you want to use this in actual production code, is to pass in the Docker image directly as an artifact through ACE and let that artifact or this Docker image be directly created as a container for you. But again, this is a demo, simple demo to show you what's all kind of possibilities. So we've chosen this way. Once the container is created, we start it. And lastly, we obtain the logs. And that log information is then sent back as part of the audit log back to the ACE server. Hopefully this gives you some idea how you can implement this in a Go. Let's look a bit into the Docker files we are using for this demonstration. I have to speed up a little bit for the time. This is a very simple Docker file that's based on a minimalistic image that contains only a busybox, which is a simple shell, Swiss Army knife, do-it-all thingy. We have the ability in ACE to make each artifact that's being deployed to each target customizable. And this is one way of doing that. So this is a placeholder. And this Docker file, once it gets deployed to a target, this placeholder will be replaced by the value of context.message. So this allows you typically, for example, if you deploy a web server, to replace it with an IP address or a port or whatever. Now we have several commands that we can run from a Docker file. In this case, we do nothing more than echo something. This is not a typical Docker file you normally would use. Normally you have Docker files that run an actual application that do long-running tasks. But we, for simplicity, chose to just use a different simple start and directly stop. This is a more complicated version. Here we have a very similar Docker file which we add a Python script. It uses a different base image, but well, that's something that contains a Python interpreter, and we simply invoke the Python interpreter using a script. So this is an example of how you can deploy a Docker file with additional scripts, if you'd like. Let's do a demo. Let's pray the demo gods are with us. Briefly going over the setup. As mentioned, there's a Raspberry Pi in front of the desk. It is a running Raspbian Lite, and it has containing serial to USB converter, just to have a serial port that I can talk to, so I see what's going on, and a USB Wi-Fi dongle, which allows it to create a Wi-Fi network. My laptop is currently connected to that Wi-Fi network, and there on my laptop the ACE server is running. And on the ACE server we have a couple of artifacts, the Docker files we just showed. Let's move this. Can everybody see this in back also? Yeah? So this is the actual terminal into the Raspberry Pi. And you see here that I simply launch the Go agent, give it a parameter with the information where the Earth server is logging and running. It logs information that is starting. It states which events it already has. In this case, it has nothing, and it starts sending its first event. It then checks if there's an update present, and it apparently is. There's a plain Docker file that I've already connected to it. And here you see the output of this container that's named like this, which is simply hello from ApacheCon. Then it rechecks which events should be sent, and it has a couple of additional events, so it does that. So this is actually the first part of the demo. How does the ACE server look like? Here's my pointer. Marcel already showed you the ACE UI of the ACE client. And what you see here are the actual artifacts. And these columns is currently how ACE envisions or sees how you should break up your artifacts into larger parts, the IKEA boxes, so to say. If I click on any of thing, for example, the target, you see how the associations are running. In this case, the Go target has a plane distribution to it, which has the plane feature to it, which is one-on-one relation, obviously, which boils down to the Docker file that is running the busybox. And given the time, I'm probably not going to make it to run a different target, a different distribution, but you have to believe me, it works. So the Python distribution, for example, contains the Python Docker file and the hello world. And if I could associate it to it and make it run that particular Docker file. Wrapping up. We've shown you, or at least we've tried to show you, that it's fairly easy to write an ACE management agent in any kind of language. So in this case, we've used Go. We could have used Python. Could have used Java, which is awkward. Is already a management agent written in Java. We've shown you how to reuse the parts from ACE to implement it for additional purpose. In this case, to provision something like an embedded Raspberry Pi. And hopefully we have shown you that ACE can do more than just provision OCI for you. That was all it. If you want to take a look, we have made, the slides will become available, and I've put all the code available on my Bitbucket repository. Here are my and Marcel's email addresses, and this is a couple of email URLs for cool projects that we are currently working on. Thank you very much. Any questions? No? Everything clear? Thank you very much then.